morning, everybody. Thank you very much. I'm going to start a small presentation on the technical part of the products that have been developed in Africultures. And we're going to do this presentation on behalf of many service providers, together with Giovanni from SIA, Malachi from SAMSA, and Haralambos and Sterios from AUF. There is a wide list of products and services that are available for Africultures. We are focusing on this presentation only on those that are relevant to the use cases that will be presented later by Professor Cipanella, and also to the products that have been of particular interest to Mozambique for food security. So it is from this wide range of services related to climate, crop, drought, land, livestock, water and weather. It's only drought that we will not present today, but it's available and operational, of course, in Mozambique as in the rest of Africa. Let's start with the crop type mapping, the service related to crop monitoring, which are expressed by products related to crop type mapping, crop condition monitoring, crop calendar, crop phenology, crop early warning, and crop yield forecast. Let's start with crop type mapping, where my colleague Giovanni will explain the work.
Thank you, Thomas. Good morning to all of you. I'm Giovanni Lani from the University of Rome. CS stands for School of Aerospace Engineering, Scuola Ingegneria Aerospaziale in Italian. This is an example of the crop type mapping that we have developed in the project. Is what I like to stress here. This is referring to one of the districts of the Mozambique, actually the Xai district in the Gaza province. And this is an example of a map of a crop made using Sentinel-2 images and a 10-meter spatial resolution. But I like to underline the name of the crop. So we put there just crop type 1, crop type 2, crop type 3, because we were able to identify the different phenology of the crop. But since we have not ground data, we cannot say the type of crop. Then in order to carry out this develop this product, we need ground information. So this is a point that I like to stress. And this is an example of this crop type mapping in which we're able to identify 3 different types of crops. Actually, we are using the land cover map as a background and our map of crop types. Then the pixels that are not classified as crop are assigned the class taken from the land cover map. You can go on the following one. Grazie, Thomas. So, based on an historical information, Sentinel-2 images, and then historical values of the NDVI, we were also able to develop this crop condition monitoring. So in each pixel, we can identify the status of the crop compared with the historical value, comparing the NDVI value of the pixel in today, the actual value, with the one that in the same period, the same pixel had in the previous 6 years. So the years are going from 2016 to 2021. This one is also based on the Sentinel-2, then 10-meter spatial resolution. Okay, Thomas. Another one of the products is the crop phenology, the monitoring of the crop phenology. In this case, we have 2 different products. One is we call it medium resolution because it's given at 100 meters spatial resolution. And this is actually taken from the FAO Vapor program. You see, in this specific case, we are comparing the crop phenology map. Actually, is the start of the season, the day of the year in which the season starts. And this is the comparison between year 2010 and 2020. Actually, you see the map is a map of the day start of the day of the day of the start of the season. Sorry. So you see, comparing 2020 with 2010, there is some difference can be shown in the are present, for instance, in the north part of Mozambique, as well in the west central part. This maroon area is increasing with respect to the 2010. The area in dark maroon correspond to brown, correspond to areas for which the phenology was not well defined. Then this can be, for instance, water bodies or areas that are not covered by vegetation. The next one. The same is done for at high resolution, then mostly devoted to the crops. So then also in case of crop, we can monitor it. We can monitor the phenology. For instance, in this in the left image on the left is shown the one of the products. The product or the file is containing 7 information. That is the start of the season, then the day of the start of the season, the day of the maximum value of the NDVI, the day of the end of the season for the first season, the second season, and the 7 layer or the 7 band of the file is the crop type. Then also in this case, if we have the phenology referring, for instance, the years 2021, we can monitor how this year the crop is compared, is the behavior of the crop with reference to the previous year. And this is shown, for instance, in the map in the right side. In this case, we see we have, according with the different areas identified as crop, we can identify where the growing of the crop is an advance, then is if we speak in terms of NDVI, the NDVI is higher than, and the phenology is in advance with respect to the previous year, or the case in which is in delay with respect to the previous year. The values are given in values that goes from -4 to 4, but they should be multiplied by 10, are given in decades, then in unit of 10 days. You can go on the next one. Also, another one of the products that have been developed is the crop early warning. Also, in this case, we have at least 2 different spatial resolution. One is this medium spatial resolution, and then the high spatial resolution. Then the high spatial resolution is devoted to crops, more specifically. This one is more general on the vegetation. The crop early warning is almost based on using the NDVI as a status of the vegetation, and weather data as the temperature and precipitation. When all these parameters are, in case of temperature, for instance, we estimate the temperature larger than in the previous 10 years. And the precipitation, low precipitation than the previous 10 years, then statistically particular values. Also the NDVI is lower than the previous years in the same period, then in that case we have a high-level early warning. Otherwise, if only one of these parameters is out of the limits, then it's not coherent with the values of the previous 10 years, so then we have different level of warnings. In the picture here in the left side, these 3 figures are referring to the case of one of the case of the Mozambique, in which we see that we have only a lower warning case because only one of the parameters is an anomaly conditions. In particular, only the NDVI presents some anomaly with respect to the previous year's conditions. You see, we can increase the yellow or light green areas are corresponding to the areas where this level 1 early warning is present. As you see, we can see as the maps are going from the 24th of October to 2021 to the 11th of December. So 1 month, one from the other. You see as this light green area is increasing, then this effect of this early warning is increasing with the moving of from October to December. Can go on the next one. This is just to demonstrate how the system is working. In case of a resolution is almost the same, then we are using the anomaly in the vegetation status, in particular estimated using the NDVI, this vegetation index, then estimating the anomaly in the temperature, anomaly higher, temperature higher than the previous years in the same period, and shortage in precipitation, then precipitation lower than its value in the previous years. Then combining these three information, we developed this crop early warning that we identify with CREW. Can go on the next. This is just an idea of how we are computing the vegetation condition index or the index related to the vegetation status or crop status for evaluating, computing this early warning. You see here just an example of the mean NDVI computed in a decade, the decade from the 1st then July, in the range of years from 2016 to 2021. This period is corresponding to all the Sentinel-2 images available, because the satellite was launched in 2015, and then the first images were available from 2016. Then we are considering all the Sentinel-2 images covering the area of interest. On the other side, we have this basic information that we need to compute this early warning. Then means the maximum NDVI in the decades. This case we considered in the decade, the minimum NDVI in the decade, and the standard deviation in the decade, and also the maximum value of the NDVI in the decade. Actually, here we are just combining the maximum value computed in different decades of the December, considering all the 6 years from 2016 to 2021. Please, Thomas, go on the... Okay.
Thank you very much, Giovanni. I will pass the floor now to Dr. Paraskevas to explain how the crop yield forecast happened in high resolution.
Thank you very much, Thomas. Good morning to all of you. In this slide, you can see the flow chart of the crop yield estimation model. As you can see in the middle, we chose a long short-term memory neural network. On the left side of the slide, you can see the input data we used. So we used the Sentinel-2 data per parcel, the ground truth yield data, and also we used the meteorological data. For meteorological data, we used the ERA5 land reanalysis data, and specifically we used the mean temperature at 2-meter height and the solar radiation. Next slide, please. Here you can see the input data for the training and testing the neural network. We had 200 parcels data. We selected randomly 150 of them as a training data set, and the remaining 50 was used as a testing data. The the training data set is a blue line, and the testing data is the orange one, the dotted one. As you can see, the yield has a large variability. Next slide, please. Here you can see the statistical results of the neural network. As you can see in the first table, the coefficient of correlation is high for both predicted training data and the testing data. And in the second table, you can see the minimum, the average, and the maximum values of yield 2 years, comparing the measured one and the predicted one by the neural network. Next slide, please. And here in these two maps, you can see the difference in percentage between the measured and the predicted values for the 2 years. The left one is for 2018, and the right one is for the year 2019. It's okay for me. Thank you, Thomas.
Thank you. This is a collaborative work with University Eduardo Mondlane on this part of Mozambique. And we're very happy to have these preliminary results and hope to have the chance to continue working on a field forecast if good data are available in other sites. Let's continue now with wide area mapping, crop condition monitoring. We use similar products like Giovanni had mentioned, the NDVI anomaly, which is a variation of the current NDVI on a single day compared to the long-term average of many years before, and the vegetation condition index on the bottom, which is a deviation of the NDVI from the minimum and maximum values of that very long time series of the past. We have estimated that at 250 meter pixel resolution and 1 kilometer resolution for the whole of Mozambique on various dates along 2021. As you can see, both NDVI anomaly and vegetation condition index were high from the beginning of the year, but it dropped toward the end. Both the NDVI anomaly and VCI have shown a poor condition of vegetation growth, which coincides with not enough rain, which we can also see in other products related to weather forecast further on in the presentation. Now, if we stop with crops and go to floods and burned area, we have been monitoring the area using VIRS products from various sources. This is at medium resolution. We cover the whole of Africa at 375 meters pixel size. And what we use is the pixel values that are classified either as dry land, as normal water, as flood water, and flood fraction, which is most important to us because it shows the percentage of the pixel that is covered by flood. You can see the area that we used for January 2021, where there was a flood incident at the mouth of Limpopo River due to the tropical cyclone Eloise. And here you can see in high resolution the reference data that we use to validate our product. And this is the product. As I told you, it's in medium resolution. So you can see along this period, at the end of January, how the flood pixels, which are in dark blue, have started to progress and increase, and then in some areas to decrease towards the end of the flood. Giovanni?
Yes, actually, as a disaster, we consider the two opposite events, floods and fires on the other side. So another product that we have developed in the project that is burned area maps. Also in this case, we have two resolutions, medium resolution and high resolution. What we are providing? We are providing, in the case of medium resolution, every 10 days, we provide the burned areas, but we are also providing what we call a burned area accumulated product, that is a map of all the burned areas occurring at specific time. Then, for instance, if we are in June 2021, this product contains all the burned areas from January to June. So at the end of the year, we can compare the present year with the previous year in terms of burned areas. But we are also providing, together with this, the type of area interested by the burn, then the land cover of the burned area, then the land cover characteristics of the area, burned area. Then at the end, we can estimate the amount of forest or crop area or pasture involved in the fires. These are two examples. Then in the right side, we have this, the burned area in particular accumulated in this year from the 1st of January to the end of January 2022. On the other side, we have an example of this LCBA. Sorry, I didn't put the map here, not the map, but the legend, but different colors refer to different types of vegetation involved in, or land cover involved in the fire. Can go on the next. This is also given a high resolution, but I have to say that we are now producing systematically this product, then providing a map every 10 days based on Sentinel-2 only for Tunisia. The idea is that the product at high resolution are provided on demand. And if requested, of course, we can apply the same algorithm applied in Tunisia to any other place, and including Mozambique, of course. Next one. Then, apart disaster, we are also trying to make some work on the water resources. One of these is the lake water quality, in which this is done at medium resolution. This is actually taken from Copernicus, is one of the Copernicus products. In this case, we are providing in particular two main parameters characterizing the characteristic of the water. These are the turbidity that is measured in this unit that is called the NTU, nephelometric turbidity unit. This is, and the other one is the trophic state index, that is an indicator of the productivity of the lake. Then the characteristic of the lakes in terms of clarity or presence of pollution. This is just an example of two lakes in Mozambique, where you can see the different value of this NTU and TU, then that is corresponding to different turbidity of the lake in different parts. Can go on the next one. We, of course, using this information, we can also make some statistical analysis all along the year. For instance, the case of Mozambique, we considered the Malawi Lake, the part of the lake that is entering in the Mozambican territory. And we see here we have, for both trophic state index and turbidity, we have the mean value that is given by the red line, and the difference with respect to this mean value. As you see, compared with the other lakes selected in Ghana and Rwanda and South Africa, the lake seems quite stable. For instance, for the point of view of the turbidity, it's very low turbidity, and also this seems almost stable during the year. It's changing not so much along the 1 year. Next one. Another product concerning, in some way, water is the soil moisture monitoring. In this case, this product is given at the low resolution. In fact, the resolution, as you can read, is given at 10 kilometers. It's provided every 10 days. You see here we have a map of this soil moisture, this quantity, and this is estimated in percentage. In some way, the percentage is related to the measurement that is usually taken for this quantity, that is cubic meter on cubic meter, then almost a dimensional quantity. This is an example of one of these maps provided every 10 days, but on the following slide, the next one, we see we are also providing this soil water condition index. So we are comparing, again, the values measured this year with the average value taken from the previous 10 years and the standard deviation. Then in this case, for instance, as you see, we have values going from -4 to 4. That means that the soil moisture is -4 means that is much lower than the previous 10 years. Positive values means that is higher than the previous 10 years. And this is values going from -4 to 4 because we are dividing the difference for the standard deviation. Then +4 means 4 times larger than the mean value, 4 times the standard deviation larger than the mean value. Anyway, if there are questions, you can ask if the things are not clear.
Okay, so very briefly, I can say that there are two products that have been developed so far for livestock. One is the rangeland type of maps, which show what type of pasture is there available during the year, the various stages of the year. And the other one is the rangeland condition map, which has to do with what is the condition of the pasture that is there. These are all a time series of products, and they have been validated using in situ data in various parts of Africa. And last but not least, we go to weather forecast, and my colleague Dr. Karchos will start presenting.
Good morning from me also. Regarding the weather services that we provide in the framework of the Africultures, we have two types of weather forecasts. We call the first type as deterministic weather forecast, and the second type is the probabilistic weather forecasts. So for the first type, the deterministic weather forecasts, we provide 5 different forecasts with respect to the 2-meter air temperature, 2-meter relative humidity, precipitation over the past 3 hours, a reference evaporation according to the FAO 56, and another product that we call precipitation deficit, that is actually measures the occurrence of precipitation over the 7 days ahead. I would like to say in this that our forecasts are provided for the 7.5 days ahead with different temporal resolutions. And on the left, the service is operational since the early stages of the project. And on the left image, you can see an example of a precipitation forecast valid for today at 2 p.m. local time in Mozambique. While on the on the right, this was for the right image. While on the left diagram, you can see the corresponding time series that is actually valid from the initialization of the forecast cycle up to 2 March 2022 in 3 hours temporal resolution. Next slide, please. We also assessed the performance of the weather forecasts regarding the 2-meter air temperature and daily precipitation. And you can see on the upper right diagram that the errors of the forecast are relatively low and in accordance with the performance over the other areas of the world. And also you can see that the errors are, let's say, consistent with the forecast lead time. So we can say that the model that we use for the weather forecasts are more or less consistent over time. Also, we validate the performance of the precipitation forecasts, and you can see an example on the left image, where you can see how the multiplicative bias of precipitation over forecast day 1 is presented. And you can see that some areas are forecasted, over-forecasted with respect of precipitation. But we can say that according to the available observations, the precipitation forecast over the forecast day 1 presents moderate to high correlations. And next slide, please. Now, regarding the probabilistic weather forecasts, we provide 5 different probabilistic forecasts with respect to air temperature and precipitation. These products are available at 3 hourly temporal resolutions, also and on daily temporal resolutions, and they are used in order to assess the probability of extremes over the areas of interest with respect to climatology. And on the right image, you can see the probability for extreme precipitation. This is the 99.9 quantile of probability for extreme precipitation for tomorrow over the Mozambique. And you can see that there is a low probability for extreme precipitation for tomorrow. And also we assessed the performance of this ensemble forecasts using different measures, different metrics. And as an example, on the left lower diagram, you can see how the ensemble behaves over time with respect to this continuous rank probabilistic skill score, which assess the performance of this kind of forecasts. So thank you very much from my side.
Thank you, Dr. Kartsos, and thank you all for your patience. I'm sorry we took a little bit longer.